Typically, the first thing you see whenever you power on your computer is the manufacturer screen. This specific screen is of no use to us. What happens next is what ultimately decides what to run on the machine. Your computer doesn't know what an operating system is. It just knows this: give me some things, I will execute. But your computer, whenever it runs, it doesn't have the operating system. The operating system is living inside the hard disk. So there is a stage that happens that ultimately checks where the operating system is and gives it to the CPU so it can run it. That's what I'm going to talk about today. I'm going to show you a little bit of the process using my own operating system, and I'm going to tell you a bit about the bootloader, and ultimately I'm going to show you how this happens. The first thing that happens is inside this file. This specific file, as you can see, is assembly. That gives us a really important realization. Your computer can't run anything besides assembly whenever it starts. The computer, whenever you run it, it looks for a specific sequence of ones and zeros inside a specific place in memory with the location of your operating system. What that tells the computer is, hey, my operating system lives in that place inside the disk. Go get it and then put it into memory, then start executing the operating system. Okay, and that's what this file does. The second stage is changing the mode of the CPU. Currently, whenever you open the computer, it starts with 16-bit mode. The problem with the 16-bit mode is that you only have 64 kilobytes of RAM to work with. That's not very cool. We would like more RAM. Most computers today have lots of RAM. So what we want to do is change to 32-bit. We have real mode, which is 16-bit, and we have protected mode, which is 32-bit. This gives you 4 gigabytes of RAM. If you want to go more, you have to go into the 64 bits, which gives you, I think, it gives you a big number. Don't worry about it, but it gives you a big number you would be happy with. We do that here in the boot2.asm. If I find 32-bit, here you can see that I'm jumping to the segment that's 32 bits, which is this segment right here, this piece of code. Okay, so now we've managed to change the mode, but there is a new problem here. Before running the operating system, we need to make sure that any user input is allowed, because without what I'm going to tell you, the user can't use his keyboard and he can't access anything. So that's what interrupts are for. Let's talk about interrupts. What is an interrupt? An interrupt is basically something that interrupts the CPU from doing whatever it's doing. It can be a click of a mouse button, pressing on a keyboard, or doing anything external, like plugging in a USB, doing whatever. Or it can be internal, as an error happened or something, okay? There are different internal and external interrupts. And whenever the computer starts and you enable 32-bit mode, you have to enable each interrupt by yourself from this chip. You do some initialization weird magic thingy, and you basically start enabling, like if we go here, I'm enabling keyboard, RTC, and the slaves interrupt. Then I need to handle this interrupt myself. This file is for handling the keyboard. Okay, now you have two things to worry about. First, how do you want to handle the interrupt, like the specific instructions, and where is your code living? You need to tell that to the CPU as well. We have a specific way of writing the interrupt. I'm not going to go into detail with this, but all I have to say is that I'm calling a function that I made inside C. Okay, so I made some C code. This is living inside here, and I'm calling it. because I don't want to write how the keyboard handling works inside assembly. That would be a nightmare. So after I read this, I need to tell the computer that, hey, I need you to know where is this interrupt living. And that is what this is for. This monstrosity is called a descriptor table. A descriptor table is basically a table that stores relevant information to your CPU. For this specific table, I'm storing all the interrupts. Where are they living at? So you can see my keyboard ISR. You can see there are two other interrupts. This one as well. This is for exception handling. This is for the clock. There are other things that I'm doing here, like, for example, if I want to initialize the keyboard, I have to do all of this in order to work. I need to worry about things like scan codes, which are basically how you have a map of key codes that are associated with each key, and you need to worry about those. There are different scan codes. Which one are you using? You need to communicate with the keyboard chip yourself. You need to tell it, hey, I want this scan code. And then whenever you talk about it with the keyboard, this is the very infuriating part. I really hate this thing. You have to wait for the keyboard to respond. And every time the keyboard responds, you have to actually read, like, it gives you some code as well. It's not like, hey, I want to use this scan code and then, sure. I'm using it. No, there are like 4 or 5 things you have to send to the keyboard before it uses the scan code. This is just the assembly part. Like, let's see, we've been talking for 12 minutes and we haven't finished all of that. Now, the state of the operating system is as follows. Let's try to run this code. Yeah, it's not pretty. It's just a command tool. It feels like it, but there are a lot of things happening in the background. The first thing, I can write text and remove it. That's pretty advanced. I can type in commands like time. It shows the time. Also, clear the screen. If I type in another command that it doesn't know, it will tell me unknown command. That's basically it. Like, let me try to close it. I like this project and I spent a lot of time understanding this. It's not just loading the operating system. It's about actually what happens inside an operating system. Memory management, disk management, network, processes, and lots of other things that I would like to talk about, but it's not really made for this video. So for now, thank you for watching and I'll see you in a bit.